So in the last lesson, we created the beginnings of our app with Create React App. I'll now go over exactly what generics are and how we can use them in TypeScript. I'm first going to create a folder called generics under source and just a file called generics.ts as an example. So in React, we often hear that it's important to design components that are reusable, whether by keeping components small or composing them in a nice way, or for example, using props to pull out any parts that can be modified for any use case. But the same is true for functions and classes that we build alongside or outside of our React components. In this course, we'll be building search, sorting, and filter functionality. And if you've ever built a large application, you often use these types of functionalities all across the app on multiple pages, areas, and most importantly, for a variety of different data types. So my first simple example is actually going to be a little preview of what we'll see in lesson 5, but a bit more simplified. So I'm just going to start with an interface called iFooBar, okay? And that is a type. It just has properties foo, which is a string, and bar, which is a string. And just to add some concrete values to what that type could look like, we'll define an array called foobars. And I'll put in just some values here. One more. So let's imagine for some reason that somewhere in our app, we would want to sort a data type like this. We get from an API a list of foobars, and we want to sort them. And say we want to sort them on the foo property. So we can imagine writing a sort function, and we'll just call it sort by foo, where we pass in some foobars. They're the same type. And we'll call the sort function, the built-in JavaScript sort function, on this array. So we have this comparator function. And we can just use the simple string comparison. So if a.foo is greater than b.foo, return 1. If a.foo is less than b.foo, return -1. Otherwise, we'll return 0. In the case they'd be equal. Then you can imagine kind of the same pattern to sort by the other property bar, which would be sort by bar, and would ultimately require changing all these to bar. And now that would actually work just fine if we were only concerned with sorting a type like this. But we can imagine a much more complex type where we have dozens of properties or even nested properties. And so we can't go around all day writing an explicit sort function with an explicit key value that would take forever and would be repetitive code. So this is a perfect use case for generics. We can create a generic function that will replace both these two functions, but also be extendable. For example, if we had a more complex type later with something like hello, it would also be able to sort on hello or any other type of property that could come into the type. So let's write that. Now the first step with generics, or to signify to TypeScript that it's a generic function, is to start with angle brackets and a capital letter. Now, there's various conventions for exactly what this capital letter is. It's usually a single letter, and sometimes it starts with T, but you can see other conventions as well. And if you need more generic types, you would continue as T, U, V, and so on with this type of convention. If you already have a little bit of experience with React and TypeScript, you may have noticed when you create a class, an example component, which extends the React component type. If you look in this type, we see also the same convention with these angle brackets. And in this case, they've chosen a different convention. The P is for props, S means state, and SS is for snapshot, but that's rarely used. But the point is that these props and states are also generic types. We know that React can use props and states in its components, but React doesn't care what shape or what type these two types are. And so this notation here really just means I'm expecting a type, I don't care what it is, and I'm going to write the logic in my class or function according to these generic types. So we'll get back to our sort by key function. And now we've signified this generic type T, and we can use that in the rest of our signature of the function. So similar to these other sort functions, we won't have array of I foobar, but we'll now have array of this generic type T. And I won't call it foobars anymore either because it's generic. So I'll simply just call it data. And that will be an array of T. And now the extension we'll need to make, instead of explicitly defining the property name, such as bar or foo, we're going to use another powerful TypeScript feature by defining a key and using key of T. And this tells TypeScript whatever type we pass as T, this key parameter in this function has to be a key of T. So I'll show an example of how that works exactly in a bit. But let's finish the body of our function. So now we can call data sort, just as we did above. Still with the AB. And the comparator now is A subkey and B subkey. And even though there is no explicit typing here, because of this key of T syntax and the way TypeScript works, it knows that we can safely access these objects with this key value, because key is a key of T. Finish that up. And return 0. So now, how do we actually use this function? When we actually call it, we can't pass a T. At execution time, TypeScript really does need a type. So in our case, if we wanted the same functionality as sort by foo, we would call sort by key and pass the specific type that we're interested in sorting. And in this case, our data is this foobars array. And the key that we want to sort, if we're looking to reproduce this functionality, is foo. And we can pass that as a string. And this line's all good. We don't see any errors or fuzzy lines. So TypeScript's happy to do that for us. Now, as I mentioned, this key of T functionality is very powerful. So if you have a very complex type, Here it's easy to remember. We have only foo and bar as our keys. But if you have a very big type, and perhaps you've forgotten or don't remember the key name, and we were to write sort by key for our foo bar type, and just anything like cat, we'll see here that TypeScript complains. It says argument of type cap is not assignable to parameter of type key of foobar. So you can look into foobar, say, why is that? Okay, we only have these properties, foo and bar. There is no cat property. But if there was, we would see that warning would go away. So just in this initial example, we can already see the power of generics, where, for example, this sort function has replaced a nearly endless amount of explicit sort functions that we would otherwise have to write by hand. So in this example, we've seen how generics can help us create flexible and reusable code, but we can also use generics to help guide our typings and not make mistakes with typings.